Hello, in today's video I will show you step by step how to create pipe bend in Autodesk Revit. This will be a step-by-step video so you can see how I'm approaching the models and what am I considering over my design. So as you can see here, I have already pre-created a pipe bend, and here when I selected it, you see that we have at least 3 different components. First component is the first component was created by a sweep, so we have just literally 2 cylinders merged to each other. Then we have a separately created elbow and another elbow to cut unnecessary parts. Why do we need to do that? The thing is, if you will try to create similar kind of shape with only one component, technically you can also do that, but then you will not be able to create a geometry, because I'm going to show you why. I'm going to delete what I created here so far. If we will try to approach the same kind of component using sweep, and you will specify the whole path since the beginning. So we need a curve, then a straight piece of pipe right after the curve, before, and of course we can give those dimensions. I'm going to add those dimensions. We need one here, another one here, just to operate with the extension length. And then we also have here another one to control the angle and make sure that this particular part is always under the 90 degree to the reference plane that controls the angle of the elbow or the bend. So once we have those dimensions here, of course I'm still missing one for the angle. I'm going to place it and lock it just to make sure that the position is fixed, and it's always perpendicular to the reference plane. Then I will assign it to L2. Yeah, as you can see, something went wrong somewhere. I made it a bit wrong, but actually I did not. So okay, that was weird. But okay, I'm just going to here and I will adjust those to 5. Okay. Yeah, this happened because we haven't attached the curve to the reference planes of the family. And now my assumption that it should be working fine. Yeah, for now definitely it will be fine because I adjusted the values. So basically that's it. Then I'm going to create a profile of this band. And here I need to navigate to the front view just to make sure that I can add diameter of the circle. It will be equal to D, so the outside diameter 1, and then we can click on finish. And from one point of view, somebody will tell that yeah, it works perfectly fine, so what? Why do we need to have a separate component for that, or to create it with such a level of complexity? Well, the thing is, if by some reason you need to have L1 or L2 equal to 0, geometry will fail, because as you must be aware, the length of the line cannot be less than 1 millimeter. If it's less than 1 millimeter, then it will fail. And To avoid such an issue, I decided to come up with totally different approach. So that's what we're going to do right now. As you noticed, the geometry is not that complex. Also the formula that we have over here, actually we have only one formula, and it's this one. So I'm going to delete this two. This one, yeah, actually this one. This is the only one based on the trigonometry. And this one is optional. Actually, we can also remove it from here. For now, it's not that important. So this will be the first one, and these two values will be the second one. Of course, including the radius and the outside diameter of the tube. So let's start to create the geometry. I'm going to clean it up also for a bit, just to show you the whole process. Yeah, I think this should be sufficient. So, what do I have here? I have one base curve under the certain radius already. And what we're going to do right now, we're going to create also sweep form, but with the straight length under the angle. So it will look like two merged cylinders. So we're going to do it like that. And actually here we're going to specify it as L. So this one will be L1 and this one will be L2, but for L2 we need to go and adjust its value just for to be equal, like that. But as you can see, once I try to change it, it intends to move according. To make sure it will remain always in the same place, we need to fix the angle under which this line always will stay. The angle will be equal to the same one, so it will be 30 degrees, and for that we can already predefine attribute that we have here. And we can move it. And now we also need to fix it, of course. And now when I change it to L2, it will remain in the same place. So look quite decent, yeah? Let's see, what else do we have over here? I also have created two support attributes or parameters over here to actually help us to control the geometry. Why? Because if we will define it to equal to 0, then geometry will fail, yeah? So the outcome still will be the same because the length of the line will be too short. That's why we need to make sure that the length will not, at least will be equal to the B. So to the actual size of the elbow, yeah? So what I'm going to do here, I'm going to specify here the condition value that will literally state that if L1 equal to 0, that it will be equal to B, and if not, it must be equal to L1. So we can close it, and here for the next value we will do the same. Click on apply, and basically that's it. The only thing right now we need to do, we need to reassign those two attributes. So here actually instead of L2 it will be LL2, and here instead of L1 it will be LL1. And now we're going to finalize it by creating the profile. Like that. Assign it there to diameter, outside diameter, then click on OK, once more on OK, and now we have such a shape. Then what we will do, we will attach to the shape our connectors. We will also define the diameter, nominal diameter of those connectors. Change the system classification to fitting and update the angle of it. And basically that's it. So probably you will have a question, why do we need to attach it to this shape? The answer is simple, because when we are going to adjust L1 or L2, this shape will move, but not the shape of the main elbow. So that's why it should be attached to this base. So next step will be to create an elbow over here that will be shown as actual elbow, yeah? Or the bend turn. You can call whatever you want. Then we can use sweep tool to repeat the same exercise. I think we forgot in the previous exercise to specify radius, but we'll move back to that. Then we're going to also to fix it to the reference planes. Click on OK, and also draw the profile. That will be equal to the diameter of the bend. Cool, this is it. Yeah, as I mentioned before, we need to move one step backward, and the only thing we need to do over here is to ensure that this line always will remain in the same position, so it will be always equal to the radius, like that. Well, technically it should be already the case, yeah, but just to make sure, we will fix it with this parametric condition. Okay, okay. And of course the last step will be to remove this edge, yeah, because nobody wants it. And for that we're going to create another bend. We will use same way of dimensioning it, but with one exception. The radius of this bend should be equal to the radius plus the half of the diameter, just to ensure that doesn't matter what will be the diameter, the edge always will be cut on. So I will call it R1. It will be also the attribute of instance, parameter of instance. I think I got confused. I used the wrong one. We need sweep, sketch, we'll repeat the same exercise. Here we'll call it R1. Instance. We're going to attach it to our reference planes. Then click on OK and also define the diameter of this subtraction form, because we will use this form as a void form to subtract this geometry out of two merged cylinders. And again, as in the previous exercise, we need to increase the diameter of it. So I'm going to call it as a D1. And also it will be not solid, but void form. That will allow us to subtract it from our main form. So I'm going to do it now. We just need to click on cut, select the form that you would like to subtract from, then subtractable, and final will be to join it with the added elbow, just to make sure that we have this seamless. So, but that's not it. We still need to define R1, that will be equal to R plus half of the diameter, and then the radius will be equal to the same. Oh, pardon. It was radius, so the radius is okay, and diameter will be simply the diameter multiplied by 2, just for sure, to make sure that this part always will be cut out. And basically that's it. Oh, okay. Yeah, now I see the issue. What we forgot to make, we forgot to ensure that the radius always will stay in place. So actually not the radius, but the curve always will stay at place. For that one, we need to fixate the center mark visible. The center mark, and for that we need to enable the checkbox, center mark visible. Okay, then we click here, then we click here, and that's it. And now, as you can see, it was solved. We will just give it a quick check. Still some Y. Yes. Because radius was not redefined. Yep. Like that. And now, with such a shape, we can be sure that this sharp edge will never appear in the model. So this was one of the ways how you can create such a shape or such a component in Autodesk Revit. If you have any questions, do not hesitate to drop them in the comments, and I will try to answer to them. Thank you for watching, and see you next time.